Hello guys, welcome to your channel which is SciEngineers. This is Sushant. We have been uploading videos for the mathematics section of the Mhtcet, and as we had promised, we have come with the video for the physics section of. So today we are going to be taking up the topic of circular motion. So if you're new to the channel, please do go and watch the playlist for Mhtcet for the mathematics section, which has over 50 plus videos in it. So do like our videos, do share our videos with your friends, and also don't forget to subscribe to our channel. Hit the bell icon which is just beside the subscribe button to never miss a notification from our channel. In the current situation, please do stay safe and keep learning, keep watching, and happy learning. So let's get going. So taking up the first question, they are asking us the maximum and the minimum tension in the string whirling in a circle of radius 2.5 meters, and it is given in the ratio of 5:3. Then its velocity is. So since they are talking about maximum and minimum tension in the string which is whirling in a circle, that means they are talking about the motion of a particular bob or a mass which is moved in a vertical circle. In a vertical circle, we know that the tension at different point is different. So we will be having the maximum and the minimum tension concept in it, and that ratio is given as 5:3. So we know that the maximum tension which this string can have is given by T1 is equal to mv square by r plus mg, and the other tension, that is the minimum tension which it can have, is mv square by r minus mg. So this ratio, that is the ratio of T1 by T2, is given by 5/3. So since it is in ratio, we can see that the m gets cancelled out, and if we just simplify this, it becomes v square plus rg upon v square minus rg is given as 5/3. So if we just cross multiply, I'll be getting this as 3v square plus rg plus 3rg is equal to 5v square minus 5rg. If we rearrange the terms, we will be getting this as 8rg is equal to 2v square. So we are getting 2v square is equal to 8rg. 2 gets cancelled, this becomes 4rg. So v is nothing but a root of 4 into r. R is given as 2.5, so into g, which is 9.8. So on calculation, we see that 4 into 2.5 is nothing but 10, and 10 into 9.8 gives you 98. So it's root of 98, which is nothing but option A. Moving ahead with the second one, they have given that if the kinetic energy of a particle of mass m, which is performing your UCM, is a circle of radius r, and it is given as E. So the kinetic energy is given as E. Find the acceleration of the particle. So we know that kinetic energy is given by the formula half m v square. So basically this thing is nothing but E. I need to find the acceleration. So in this case, since it is your UCM, the acceleration which they are talking about is nothing but your centripetal acceleration. So we know that acceleration is given by the formula A is equal to, that is acceleration EC is given by v square by r. So from this, if I just I need to find what is v square. So from this I can get v square is nothing but 2e by m. So if I just substitute v square, I'll be getting this as 2e by mr, which is nothing but option A. So moving to the third question, we have a car whose wheel is rotating with a certain angular frequency or angular velocity and is stopped at 5 seconds in 5 seconds, and before it stops it makes 20 revolutions. I need to find what was the initial frequency with which it was rotating. So let us just write the data which is given. It is giving you that I need to find the initial velocity, initial angular velocity, and then I need to given that time is 5 seconds and the rotation is 20 revolutions. I need to convert it into radians, so that is 20 into 2 pi, which is nothing but 40 pi. So these are the information, and one more information, that the final velocity is 0. So I need to first of all find with what angular acceleration is the wheel being stopped. So I need to find alpha. So alpha, you can see it is given by the final velocity minus the initial velocity upon the time t. So the final velocity is, it's 0, and initial velocity is what we need to find. So we are just getting a relation of alpha and omega I. After this, since theta is given, we can use the formula, which is theta is equal to omega I t plus alpha t square, half alpha t square. So in this I can just substitute alpha. So alpha is nothing but omega I by 5, and my t is also 5. So just substituting those values. So theta, which is given by 40 pi, is equal to omega I t, so that's 5 omega I, and minus, this is omega I into omega I divided by 5 into 5 square half. So the 5 gets cancelled, so this becomes 5 by 2 omega I. So it's 5 omega I minus 5 by 2 omega I, which is nothing but 5 by 2 omega I. So from here I'll be getting omega I. Omega I goes there, it becomes this 5 8s are 40, this goes that side, so that is 16 pi, but I need to find the frequency. So omega is nothing but 2 pi f, since we are talking about frequency, which is in hertz. So this gets cancelled with this, and I get this as 8 hertz. So that's nothing but option A. Moving to the fourth question, we have been given the length of the pendulum, which is 2 meters, and the mass, which is 2 kgs. It is telling that the string basically can sustain a maximum tension of 100 newtons, beyond which the string will break. They have given me g, which is the gravitational acceleration, which is 10 meter per second, and the bob is whirled horizontally, so it's basically moving in a horizontal direction, and the maximum angle through which the string will be making with the vertical. So diagrammatically, if we see, this is my string, it is being whirled. There is a bob which is placed at this point, which is of mass 2 kgs, and I need to find what is the angle with which it's going to be making this revolution. So it's fixed at this point, and it is rotating about this. So we know there's a tension which is there T. So this is the maximum tension which it can have is 100. Beyond this, the string will break and the ball will basically be flung out of the rotational motion. So because of that, there is a weight which is there, that is mg. Now we know that my T, that there is the tension, has to counteract with the weight, that is mg. So I need to basically find the component. So this component is going to be nothing but, since this is theta, this is also theta, it's going to be t cos theta. So I'll be getting the relation, that is t cos theta is equal to mg. Now why I have gone to this particular relation is because of the answers which are given to us. The answers are talking about cos inverse, so I have to incorporate a term which is of cos theta. So since they have given the tension, that is maximum tension, the mass is given, and the gravitational acceleration is also given, I'll be getting cos theta is equal to m, which is 2, into g, which is 10, divided by t, which is 100. So one of the zeros gets cancelled out, and I'll be getting my theta, which is cos inverse of 2 by 10, which is nothing but option C. Moving on to the next one, which is the fifth question. The figure shows a circular path of a moving particle. If the velocity of the particle at some instant is v is equal to minus 3i minus 4j. So this is the direction in which the velocity is given. Through which quadrant is a particle moving when it is going in the clockwise direction and when it is going in the anti-clockwise direction. So let us just try to understand. This is a path which is given along which the particle is going to be moving. Either it can move in the clockwise or the anti-clockwise direction. And they have given at some instant the velocity Now this velocity is basically the direction of the velocity which is given. So let us just understand what direction they are talking about. They have given minus 3i, so that's along x-axis. So minus 3 is along x-axis in the negative direction of x-axis. And it is minus 4j, which is also along the negative direction, but along the y direction. So if I just find the resultant of this is the basic direction which they are talking about. Now, when it is going in the clockwise direction, you can see clockwise means it's in this direction, that is, the particle is going to be moving, and you have to find at which location will the velocity be in this particular direction. So you can see obviously it should be in this quadrant, that is the fourth quadrant. So when it is rotating in the clockwise direction, it will be in the fourth quadrant, and when it is rotating in the anti-clockwise direction, which is the opposite direction, which is this direction in this way, so it will be in the second quadrant. So they are talking about clockwise, anti-clockwise, and that's nothing but the fourth quadrant and the second quadrant. So that's nothing but your option. Moving ahead with the next one, they are asking what is the difference of the angular speed of the minute hand and the second hand of a clock. So we know in a clock basically minute hand and second hand both perform a circular motion, and the circular motion is always in a it's going to be taking entire circle around the clock. So let us understand the minute hand. The minute hand will be traveling the same distance of 2 pi, that is the entire circle, and it takes 60 into 60 seconds. So this is nothing but the angular speed of the minute hand. Talking about the second hand performs the entire motion, that is of 2 pi, in 60 seconds. So this is the angular speed. So I need to find the difference. Obviously the second hand is going to be the speed will be higher. So I need to find omega s minus omega m. So that is 2 pi by 60 minus 2 pi by 60 into 60. So we can take the 2 pi common, 2 pi by 60 common. That becomes pi by 30, and inside the bracket I will be having, since I've removed 2 pi by 60, this is going to be 1 minus 1 by 60. So if I take the LCM, this becomes 60 minus 1 by 60, which is nothing but 59. So it becomes 59 pi divided by, it is 1800. So that's nothing but your option B. Moving ahead with the seventh question. So a car of mass 1500 kg is moving with a speed of 12.5 meter per second on a circular path of radius 20 meters on a level road. What should be the coefficient of friction between the car and the road so that the car does not slip? So let us try to understand what the question is. So let us consider this as a road, and this is a car which is basically performing the rotational motion. So this is the car which is performing the rotational motion. These are the wheels which are present, and it is going to be performing the rotational motion in this way, and its velocity is given as 12.5 meter per second. It has a weight which is mg, which is 1500 into g, which is 9.8, and this road and the tires are basically having some friction between them. So I need to find what is going to be that coefficient of friction between the road and the tires. Now if this particular car has to move in this particular in the circular motion, then the friction should provide the centripetal force, or the force which is required for the circular motion. So that means my centripetal force, which is nothing but mv square by r, is to provide the frictional force. Now understanding the frictional force, since mg is downwards, that is weight is downwards, there is going to be a normal reaction because of this road which is upwards, and my frictional force is given by mu into n, that is mu into normal reaction. Mu is coefficient of friction. So normal reaction is counteracting the mg part, So it is mu into n, and n is nothing but mg. So this is the relation which I get. The m gets cancelled and I need to find mu. So mu is nothing but v square by rg. Now v square is given by 12.5 into 12.5 divided by r, which is the radius. Radius is given as 20 into 9.8. Now let us consider now for simplicity of calculation, we can consider instead of 9.8 this as 10. This is just for simplicity's sake. And we can write this 12.5 as 125 by 10 and by 10. So if let us just simplify this because this calculation has to be done quickly. So if I just divide by 5, this becomes 5 2s are 25, so 25 and this 2. Again if I subtract, so this becomes 2, 2. One more 5 can be cancelled from this. So this is 4 and this is nothing but my 25. So now if I do the cancellation, so 2 gets cancelled, this becomes 12.5. This gets cancelled, this becomes 6.25. One more cancellation, this becomes 3.125. One more 2 cancellation, that is 1.5625. And one more cancellation. Now this can be approximated as 1.6. So if I do one more cancellation, it's going to be 1.8. So 1.6 divided by 2, which is 0.8. So you can see it's nothing but option D. So you can do a minor changes while calculation, so that you can just find an approximate answer. So as you all know, we have started this particular section wherein we give you for revision certain sets of questions for your practice purpose. So these are the 2 questions which are given to you. So the questions are: a wheel has a speed of 1200 revolution per minute and is made to slow down at a rate of 4 radians per second square, and what is the number of revolution it will make before it comes to stop. And the next one is the maximum speed of car on the road which is turning around the radius of 30 meters, and the coefficient of friction is given as 0.4, and what is the speed, which is what is going to be the maximum speed it can have. Do write in the comment section what do you feel the answer should be, and we'll be discussing on these 2 questions in the next video. Thank you guys for watching our video. Do let us know in the comment section how do you find this particular new segment which we have started, which is for the Mhtcet physics section. Write in the comment section what more videos you would like us to make on, what topics you would like us to cover on. So do like our videos, do share it with your friends, and do subscribe to our channel. Also hit the bell icon which is just beside the subscribe button. So keep learning, keep watching, and happy learning. Bye.